It says make a scatter plot with efficiency on the x-axis, salary on the y-axis, and paste the scatter plot below. Make sure to include the trend line and r squared. So what we're going to do is I will copy and paste this in a new sheet. Let's see, I'll delete this. Okay. So I'll copy and paste in a new sheet. I think it's always just better to do when you're making a new graph. So I'm going to copy efficiency, and I'll put that first because that's in the x-axis. So efficiency, and then salary. Salary, copy, and paste. So let's select all this. Actually, I'll just kind of click up here like that. Insert chart. And usually it's not the right type of chart. This actually is, which is nice. So efficiency is in the x-axis, salary is in the y-axis. It looks moderately strong, positive. I would call this linear. It's linear enough. So if I need the trend line in r squared, I'm going to go over to customize. I'll go to series, trend line, show r squared, and I'll get the equation just for fun. All right. So the r squared value, it asks for include the trend line in r squared. So I'm just going to copy and paste, copy chart, paste unlinked. I'll always paste unlinked. So I have r squared and the trend line. So I've done that first one. That's done. All right. So describe the form, direction, strength. So form is linear. Direction is positive. Strength is, well, let's see. Our r squared value is 0.426. So r is going to be the square root of that. Our correlation coefficient is the square root of that. So correlation coefficient, it's always just the square root of r squared. So equals the square root of our r squared value is 0.426. So our correlation coefficient is 0.65. So I'm going to say this is moderately strong with correlation coefficient of 0.65. We also can find the correlation with a function. So I'm going to go up here, say equals correlation. Why is it not coming up? It should be coral. And then your x data. And your y data. It would be the same if you put y first or x first. So yeah, we got a correlation coefficient of 0.6528, and here we got 0.6527, so close enough. All right, so I'm going back. Describe the form, direction, strength. We've done that. Form is linear, direction is positive, strength is moderately strong with a correlation coefficient of 0.65. What is the r squared value, and what does this number mean? So r squared is up here in our scatter plot. So r squared is 0.426, which means that 42.6% of the variation in salary can be explained by variation in efficiency. Another way to say this is 42.6% of the variation in salary can be explained by our linear model. You can say it either way. Identify a player who is very overpaid for his efficiency, and what is his residual. So I'm going to go back to my scatter plot. And what does it mean to be overpaid? Well, that would mean the actual salary, so the dot the point on the scatter plot is much higher than the line. So I could look at this point here, this point here. This person's definitely overpaid for their efficiency. So I would say maybe this player, this player, this player stand out. I will look at this player here because they have a very low efficiency, 8.3. So that little number up there is the X value, 8.3. And their salary is 14.72 million. So they have a low efficiency, high salary. So I'm going to go to my, I'm going to look for 8.3 as an efficiency. I'll look for my first sheet. Why don't I just do, I'm going to look for 8.3 here. I can just search for it. So Control F, 8.3. That only shows up 9 times. So let's find it in efficiency. No, it's 18.3. No, that's not it. That's not it. That's not it. And it's the last one, of course. So down here, I see the player with efficiency of 8.3. And if I follow, that's J.R. Smith. So J.R. Smith is a player that's very overpaid given his efficiency. So I will go here. Who's overpaid for their efficiency? J.R. Smith is overpaid given his efficiency. And then it asks, what is his residual? So I'm actually going to need to find the equation of our line. So if I go back and I go to our scatter plot, I included the equation. So the equation is up here. And you'll notice it says 1.17 E plus 06. So that E, it's like times 10 to the 6th power. So we need to move the decimal place over 6 places to the right. So I'm going to write the equation here, our predicted salary, which is y hat, equals. It's not 1.17. We're going to move the zero or the decimal over 6 times to the right. So it's 117, but we've moved the decimal over 1 time, 2 times, now 3 times, 4 times, 5 times, 6 times. So it's actually 1.17 million times X, so times their efficiency, minus, see how it says plus a negative, so that's minus 5.74 E plus 06. So it's the same thing where we need to move the 0 over 6 places to the right. So instead of 5.74, it's 574. And we move the decimal over 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. So this number is actually 5.74 million. So our predicted salary, y hat, equals 1.17 million, or 1,170,000 times X, which is the efficiency, minus 5,740,000. So I'm going to use this equation to find J.R. Smith's predicted salary, given his efficiency. So his predicted salary, predicted J.R. salary, equals 1,170,000 times his efficiency, and his efficiency is 8.3. Times 8.3 minus, or actually, I'm going to copy and paste this into a new cell because it won't do the math because I have letters there. So I'll just do it down here. Equals, paste. Now, of course, I have 2 equals. All right, 1.17 million times 8.3 minus 5,740,000. Error. So what's my error? It's probably using commas. So I'm going to use no commas. 8.3 minus 5. See if that did it. That was it. No commas. So it says my predicted salary is $3,971,000. so $3,971,000. So if my predicted is $3,971,000, $3,971,000, and my actual or observed salary for J.R. Smith, what was his salary again? I can go back. So J.R. Smith is down here. His salary is $14,720,000. Where am I going? So his observed was $14,720,000. Then my residual equals my observed minus my predicted. So his residual is $10,749,000. His residual is $10,749,000. And that means that J.R. Smith is paid $10,749,000 too much given his efficiency, assuming our model is the best way to predict efficiency. Assuming our model is the best way to predict salary. So let's find a player who's very underpaid, a player who's underpaid. So I'm going to go to my scatter plot. Underpaid would mean that the dot is much lower than the prediction. So this player is low, this player is low, but the biggest distance between the point and the line is probably this player here. So this player is probably the most underpaid. So whoever has an efficiency of 29.1 and a salary of $7,839,000. So I'm going to search for that, an efficiency of 29.1, and there's only one of those. Nice. So I'm going to go over. That is Carl Anthony Towns. So Carl Anthony Towns is underpaid. So now what is his residual? We're going to do the same thing. So to find his residual, his efficiency is 29.1. All right, so our model says the predicted salary, is 1,170,000 times, remember no commas, 1,170,000 times the efficiency of 29.1 minus 5,740,000. So his predicted salary is 28,307,000. Observed is his real salary, which is, if I go down here and hover, 7,839,435. 7,839,435. Oops, that didn't go in. 7 million, what was it again? 7,839,435. 7,839,435. That's what is observed, and the residual is observed minus predicted. It equals observed minus predicted. So this residual, I'll just copy and paste this. It's negative 20,467,565. So that means that given his efficiency, he's being paid $20,467,565 too little, because that's a negative residual. So the observed is much lower than the predicted. So now the last question is, what is the predicted salary of a player with an efficiency of 25.2? So we would need to use our linear model again and find our predicted when x, or the efficiency, is 25.2. So that equals, our equation again is 1,170,000 times x, the efficiency of 25.2, minus 5,740,000. So this player's predicted salary is $23,744,000.